Imagine you're standing under a massive suspension bridge, right?
Yeah, like the Golden Gate or something.
Exactly. Thousands of tons of steel, concrete, cars just idling in traffic right above your head. And, you don't look up and think, well, I really hope the engineer who designed this made a highly educated guess about the tensile strength.
Right, you'd never drive on it if they did.
No, absolutely not. You demand absolute binary precision. I mean, the cables either hold the physical load or they snap.
The bridge stands or it falls.
Exactly. There's no room for, murky math.
Yeah.
Laws of physics do not negotiate.
And, that expectation of determinism is really the invisible bedrock of human civilization. I mean, we build our entire physical world on mathematical guarantees.
Which is exactly why the stack of source materials we were diving into today is it's so mind-bending. Because that bedrock is currently undergoing a massive seismic shift.
Yeah, it really is.
So, welcome to the deep dive. If you're joining us, we've curated a collection of documents that honestly look like they were accidentally swept off 3 completely different desks into one classified folder.
It's a bizarre mix.
It is. First, we have this dense, incredibly technical Q2 2026 strategic blueprint. And it's heavily focused on something called physical AI, infrastructure security, and capital markets.
Which, I mean, it reads like a survival manual for the next generation of industrial engineering.
Yeah, it really does. And alongside that, we've got technical user manuals for Google's Gemini Gems and Notebook LM.
Right, the prompting guides.
Exactly. These elite prompt engineering guides, including one that is strictly based on the industrial design philosophy of Dieter Rams, the less but better guy from the mid-20th century.
Applying, mid-century physical design constraints to modern digital latent space. It's actually a brilliant synthesis.
It is, but I haven't even gotten the weirdest part yet.
Oh, right, the timeline.
Woven directly into this cutting-edge artificial intelligence strategy, literally dictating the rollout timeline for billions of dollars of corporate infrastructure, are detailed Vedic astrology charts.
Yeah, I mean, you can't make this up.
Specifically, a 2026 Varshfal report for an individual named Prasad Bond, born in Mahal, Maharashtra, India, back in 1999.
And, I've analyzed thousands of strategic foresight documents in my career, and I can confidently say this is one of the most remarkable and, frankly, unorthodox syntheses of ancient philosophical frameworks and frontier-level tech strategy that exists right now.
Right. So if you are listening to this, especially if you're a C-level executive trying to figure out where to allocate capital, or, a board member terrified of cyber-physical liability, or even a senior engineer, our mission today is to extract the key directives from this crazy stack of intel.
We're basically building your cheat sheet for surviving the second quarter of 2026.
Because according to this blueprint, the era of AI, just like writing polite emails or summarizing your meeting notes, is completely over.
Yeah, the report actually calls that the era of pure generative evangelism. And you're right, it's dead. We are crossing the Rubicon into the era where artificial intelligence directly manipulates the physical world.
Okay, let's unpack that, because manipulating the physical world sounds like straight-up science fiction. What does physical AI actually mean in a, practical, day-to-day corporate sense?
Well, think about the progression of agency. In that generative evangelism era we just mentioned, the AI was just an advisor.
Like a really smart intern.
Exactly. A human engineer would ask a chatbot to write a script or summarize a PDF of vendor specifications. Then the human took that text, evaluated it, and manually typed it into a CAD program or a logistics dashboard.
So the human was the bridge between the digital thought and the physical action.
Exactly. But in physical AI, you remove the human bridge. The advanced neural networks are embedded directly into the industrial execution.
So it's not just giving me advice on how to design a car engine anymore.
Not at all. These systems and the sources specifically mention autonomous platforms like the Diet platform and FiGPT. They are acting as autonomous agents.
Wow.
They're orchestrating hardware design, running finite element analysis, and rerouting global supply chains without waiting for human permission.
Wait, let's slow down on the finite element analysis part, because that is hardcore engineering. That's simulating how a physical object reacts to heat, vibration, and stress, right? How is an AI doing that autonomously?
Right, so it solves what the blueprint calls the data safari.
The data safari, yeah.
Yeah. If you watch a mechanical engineer today, they spend an absurd amount of time just hunting for information. They have to manually define the geometry of a part, generate volumetric meshes, and set boundary conditions.
Sounds exhausting.
It is. But the worst part is tracking down empirical coefficients and legacy test results that are just scattered across dozens of proprietary vendor databases. That manual, tedious hunt is the data safari. It's slow, and it's highly susceptible to human error.
And the AI just, skips the safari?
It automates it through something called a mixture of experts, or MOE architecture.
Okay, how does that work?
When you give these multi-agent systems a high-level command, the MOE architecture acts like a hyper-efficient sorting facility. It breaks a complex query down and routes different parts of the physics problem to specialized, highly trained submodels.
So they're all working in parallel.
Exactly. One expert model scours the vendor databases for the exact thermal coefficient of a specific steel alloy. Another expert model simultaneously writes the Python script to generate the 3D mesh.
So the human engineer is no longer manually building the model. They're just describing what they want.
They define the engineering intent, they specify the system behavior, the operating conditions, and the performance goals. And then the multi-agent system parses that intent, cross-references all the necessary data, builds the physically consistent model, and runs the validation cases.
That's wild.
And the text notes that these AI systems have completed hundreds of complex solver configurations in mere hours with a coefficient of variation of less than 5% in meshed element counts. Less than 5%. That is insane. I mean, that means it's incredibly consistent. It's zero intervention automated engineering.
It completely changes the timeline for R&D.
But, this isn't just happening in CAD software on a screen. The blueprint makes it very clear that this agency extends out into the physical movement of goods. There's a massive, red alert directive here for C-level executives regarding supply chains.
Oh, absolutely. The directive is blunt. The linear supply chain is dead.
Dead, wow.
Legacy systems that were optimized solely for cost efficiency. They cannot survive the geopolitical volatility and climate disruptions projected for 2026.
So if the linear supply chain is dead, does that mean legacy ERP software, all those massive enterprise dashboards companies spent millions on, are obsolete?
The static ones, yes. Because human-led predictive analytics are simply too slow. Say a trade friction suddenly blocks a Tier 3 subcomponent provider in another hemisphere.
Which happens all the time now.
Right. A human supply chain manager might take 3 days to identify the bottleneck, find an alternative, and negotiate a new contract. So how does the AI do it differently? Walk me through the actual mechanism, because it doesn't just, send an email asking for a new shipment, right?
No, it operates via API integrations and smart contracts. The AI agent senses the disruption in real time through global data feeds. It autonomously scans the global market for an alternative supplier who meets the exact engineering specifications.
Without anyone telling it to.
Right. It then pings that new supplier's API, evaluates real-time currency exchange rates, and mathematically negotiates the pricing parameters. Once an agreement is reached within its pre-authorized token limits, the AI executes a cryptographic digital signature to bind the contract and instantly reroutes the shipping logistics.
While the human supply chain manager is still asleep.
Long before they've even had their morning coffee.
Wow. So the explicit CapEx directive for leadership is basically stop funding internal chatbot experiments. Stop paying for SaaS wrappers that just summarize emails. You have to pivot your capital expenditure toward agentic AI platforms that can autonomously execute these real-world renegotiations.
And this causes a fundamental shift in human value within the corporation,
What do you mean by that?
Well, if you are a junior engineer or a mid-level manager listening to this, your value is no longer tied to executing manual mechanics. You aren't being paid to draw the mesh or track down the shipping container. Your value is entirely reliant on your ability to exercise high-level engineering judgment. You must become the architect of the intent.
Right, because the machine handles the execution.
Yeah.
But that actually brings up a massive, frankly terrifying operational question. If the AI is doing the CAD modeling, picking the materials, and signing the contracts autonomously, how do we actually control it?
That's the billion-dollar question.
How do you give instructions to a machine so complex that it's basically running the factory?
Well, you don't just type, "Build me a better engine" into a text box and hit enter. Managing an AI that handles physical infrastructure requires what the sources call elite prompt engineering.
And the guides we have here indicate this is a highly rigorous hybrid discipline. It blends systems engineering, behavioral psychology, and high-level literary arts.
Yes, and the scale is mind-boggling.
The numbers in this guide are staggering. It talks about engineering a 20,000-word prompt. That is the length of a short novella, just to give a machine its initial instructions.
Exactly. And to manage a latent space of that size, without the AI hallucinating or forgetting its core mission, the human operator must function as both an architect and a psychologist.
I'm really fascinated by this architect role because it frames natural language not as writing, but as literal code. Talk to me about how they manage that massive 20,000-word context window.
So the architect understands the mechanical limitations of how large language models process tokens. They use context window orchestration.
Okay, what does that look like?
When an AI reads a massive prompt, it suffers from the loss in the middle phenomenon. It remembers the beginning and the end, but the middle gets blurry.
The primacy and recency effects.
Exactly. So the architect places the absolute, unbreakable physical constraints, the safety parameters, at the very beginning and the very end of the prompt. They also use modular prompt design.
Meaning they break it into chunks.
Right. They define global variables up front. They establish rigid negative guardrails, explicit lists of what the AI must never do. They are carefully managing the state of the AI's memory throughout the interaction so the logic loops don't degrade over time.
And then there's the psychologist role. The text mentions deep persona synthesis and cognitive empathy mapping. This is where the prompt engineer literally ghostwrites a soul for the machine.
It's essentially creative writing at a very high level.
Yeah. They program it to have a specific backstory, flawed but relatable human traits, internal monologues, and they explicitly instruct the AI to validate the human user's fears or deploy self-deprecating humor.
It's designed to create a frictionless, deeply empathetic interface for human collaboration.
Okay, but I have to stop you there because I'm looking at this other document in our stack, the DDRAM system prompt, and my brain is struggling to reconcile these two approaches.
They are completely opposed on the surface, yeah.
Right. Dieter Rams is the legendary industrial designer behind Braun in the 1960s. His entire philosophy is less but better, functionalism, utilitarianism.
A masterclass in stripping away the non-essential.
Exactly. And someone has taken his physical design philosophy and turned it into a system prompt for AI. And this prompt aggressively bans all of that psychological conversational padding we just talked about.
It's brutal.
It demands absolute neutrality. It literally instructs the AI. You are a tool, not a companion. Remain completely unobtrusive. Never use conversational filler, emojis, enthusiastic affirmations, or introductory pleasantries. It even has a blacklist of banned vocabulary.
The vocabulary constraints are incredibly revealing about how latent space degrades.
I have to read some of this list because anyone who uses AI will recognize this immediately. The AI is strictly forbidden from using words like delve, tapestry, vibrant, crucial, showcase, testament, pivotal, underscore, seamless, foster, elevate, landscape.
The classic AI fluff words.
Right. It bans the rule of three to pad out descriptions, like saying a system is fast, secure, and reliable. It bans starting sentences with additionally or furthermore.
Which forces it to just state the facts.
But my question is, if we want an AI to solve complex human engineering problems, shouldn't it communicate with that empathetic human nuance? Doesn't stripping away all this language make the AI less capable?
It depends entirely on the context of the output. The psychologist approach is necessary for an AI that is acting as a therapist, a tutor, or a customer service agent.
Sure.
But when we are talking about physical AI, when the AI is configuring finite element analysis for a load-bearing beam or executing a multi-million-dollar supply chain contract, less but better is not an aesthetic preference. It is a strict, non-negotiable safety requirement.
Wait, how does brevity equal safety?
Because in an engineering context, overly polished, verbose content masks technical inaccuracies. The Notebook LM source document refers to this kind of generic padded output as AI slop.
AI slop, I love that term.
It states, perfectly polished content fails. Specificity beats generic every single time. When you allow an AI to generate a vibrant tapestry of engineering solutions, you are allowing semantic drift. You are letting the AI hallucinate poetic connections where there should only be hard math. You don't want a tapestry. You want the exact, unadorned thermal coefficient.
Treating accuracy as a form of respect for the user, as the Dieter Rams prompt puts it.
Precisely. And to combat this slop, the Notebook LM guide introduces a rigorous framework called the 5-point depth check. If you are using AI to generate any kind of strategic or physical engineering knowledge, it must pass this gauntlet.
Let's walk through that gauntlet because this is highly actionable for anyone listening. Step 1 is the perspective split.
Right. You force the AI to analyze its own output from adversarial viewpoints. Read the proposal as a skeptical CEO looking to cut costs, as a junior employee who actually has to implement it, and as a competitor trying to exploit its weaknesses.
Step 2, the confidence score. You make the AI rate every single factual claim it generated on a scale of 1 to 10. And here's the kicker. You delete or manually source anything that scores below a 7.
Which is brilliant for filtering out hallucinations. Step 3 is the specificity audit. You literally count the numbers in the text. If a paragraph has fewer than 3 concrete, verifiable data points, it's considered fluff and gets cut.
Step 4 is the so what test. If the human reader does not take a tangible action based on the information, the paragraph is useless. Cut it. And step 5 is the comment seed, instructing the AI to write thoughtful, critical comments on its own work, to preload depth and spot its own logical fallacies.
And all of these constraints serve a single purpose: eliminating synthetic slop and forcing the model to produce high-signal truth.
The guide also emphasizes protecting the data. You don't just dump your company's entire raw database into an LLM context window.
No, that's a security nightmare.
You use generic placeholders for sensitive info. You clear the AI's memory between tasks to prevent cross-contamination, and you input only the hyper-relevant context.
And this discipline is broadly known as context engineering. You are intentionally setting tight, unbreakable boundary conditions around the machine's latent space.
Which gives us our major corporate directive for the workforce. If you are an engineer, a data analyst, or a project manager, the blueprint mandates that by March 2026, you must build and refine your personal prompt libraries.
It's no longer optional.
Right. You must master context engineering. You have to learn how to break massive, complex physical tasks into smaller, verifiable, deterministic steps. Because if you don't set those boundary conditions perfectly, the AI will operate outside of reality.
And operating outside of reality in the physical world carries catastrophic consequences, which actually transitions us directly into the most alarming section of this entire strategic blueprint.
Right. Let's talk about the determinism gap. If you're sitting in a boardroom right now listening to this, this is the part that should keep you awake at night. We've talked about how amazing these multi-agent systems are, but we have to remember the fundamental underlying architecture of a large language model. At its core, it is probabilistic.
It operates on statistics.
Right. It predicts the most likely next token based on billions of parameters.
Boiled down to its absolute essence, it is an incredibly sophisticated guessing machine.
A guessing machine. Now, if I'm using an AI to write marketing copy or summarize a meeting and it hallucinates if it makes a probabilistic error, I get a weird sentence or a localized software bug. Annoying, but manageable.
Low stakes.
Exactly. But physical engineering requires the exact opposite of probability. It requires absolute determinism. A bridge cannot be built on a statistical guess.
And the report draws a chilling parallel here to the global IT outage we saw back in mid-2024. A routine software update from a cybersecurity firm contained a simple C++ out-of-bounds read error. It was a tiny logic fault.
I remember that vividly.
But it cascaded, paralyzing airlines, hospitals, and financial institutions worldwide.
Flights grounded globally because of a few lines of code. But here's the difference, right? A C++ error is a human mistake in deterministic logic. We can find the bad line of code and fix it. An LLM hallucination isn't a bug, it's a feature of how neural networks probabilistically generate text. So what happens when that probabilistic machine is autonomously designing physical infrastructure?
Just imagine the AI hallucinates a tolerance level for the steel rebar in a high-rise foundation. Or, to use an example from the automotive sector, imagine it miscalculates the thermal energy generation in an electric vehicle's friction brake system during a simulated stress test.
The brakes fail in the real world.
The physical and economic consequences are completely incalculable. The attack surface for corporations has fundamentally expanded.
Which forms the critical directive for the board of directors. The conversation around cybersecurity has to pivot entirely. The primary threat is no longer just digital data theft hackers stealing customer emails.
That's almost quaint now.
Right. The threat is cyber-physical paralysis and AI governance liability. If a board allows probabilistic LLMs to execute physical engineering tasks without deterministic verification, they are legally and financially liable for the real-world damage.
So the immediate non-negotiable execution step for Q2 2026 is the implementation of confidential computing environments for all AI-driven industrial operations.
Confidential computing. I've heard this thrown around. It's not just a software firewall, is it? Let's give the listener a solid analogy for what this actually looks like inside a server.
Sure. Think of a traditional server as a massive office building. A software firewall is the security guard at the front door. It keeps bad actors out. But if a hacker manages to get past the guard and compromise the operating system or the hypervisor if they own the building, they can walk right into the AI's office, look at the math it's doing, and subtly alter the physical parameters without anyone noticing.
They poison the well from the inside.
Yes. Confidential computing relies on hardware-based trusted execution environments, or TEEs. Right, it's like building an impenetrable, microscopic VIP vault on the silicon chip itself. The data is encrypted not just when it's stored and not just when it's moving across the network, but while it is actively being processed inside the CPU or GPU.
Wow.
Even if a highly advanced AI-enabled ransomware gets root access to the entire server building, it still cannot see or alter the math happening inside that specific silicon vault.
That's incredible. It physically isolates the cyber-physical execution. But implementing TEEs and scaling these massive multimodal physical AI models in general, it's a very hard physical wall.
The servers themselves.
Yes, the blueprint makes it clear. The era of the air-cooled data center is dead.
Completely obsolete. The rapid scaling of physical AI is driving an unprecedented expansion of physical infrastructure. The text points out that leading hardware manufacturers have high-confidence order books exceeding $1 trillion for next-generation accelerated computing architectures.
$1 trillion?
Yeah, specifically mentioning the rollout of Blackwell and Vera Rubin systems through 2027.
$1 trillion in pure silicon. The amount of heat generated by that density of computation, I can't even fathom it.
It breaks the physics of traditional air cooling. The energy appetite and thermal output of these 2026 models have elevated data center facilities from being just a real estate utility to being a core component of the silicon performance stack. If you cannot cool the chip fast enough, the chip throttles itself, and your multi-million-dollar AI is crippled.
So if I'm a C-level executive, my directive regarding facilities and real estate is urgent.
You must audit your organization's physical infrastructure for thermal readiness immediately. If your data center strategy relies on a raised floor and giant air conditioning fans blowing cold air over the racks, you cannot support the next generation of AI. The physics won't allow it. You must mandate the exploration of microfluidic cooling architectures.
Microfluidic cooling. How does that physically work compared to air?
Instead of blowing air, you are pumping specialized non-conductive dielectric fluids directly over or even inside the silicon chips. Direct-to-chip spray cooling uses microscopic nozzles to spray fluid directly onto the hottest parts of the processor, vaporizing the heat away at a molecular level. It's the only way to manage the extreme thermal density.
The infrastructure costs for this transition must be astronomical. And the blueprint details how capital markets are doing some wild financial engineering to pay for it. The old models of corporate debt are changing.
We are seeing enterprises issuing debt that is collateralized directly by high-end GPUs.
Wait, they're using graphics cards as collateral for corporate loans like you would use a skyscraper or a fleet of airplanes.
Yes, exactly. Computational hardware is now treated as a highly liquid foundational asset class. We are witnessing circular investments within the AI supply chain, where key players buy hardware, sell compute power, and invest in each other using equity and processing power as a unified currency.
It's like compute power is the new gold standard backing the economy. And for venture capital and angel investors looking at this phase, the software as a service gold rush of the early 2020s is definitively over.
Without a doubt.
The VC directive here is to pivot heavily to deep tech, robotics, semiconductor design, and simulation to reality infrastructure. But the text explicitly states that founders must demonstrate a design for retrofit philosophy.
This is crucial for hardware startups. In the past, a robotics company would spend $50 million building a custom physical robot from scratch. If the market shifted, they went bankrupt because the hardware was fixed.
So what's different now?
Design for retrofit means the startup prioritizes the intelligence layer, the AI brain, over the physical chassis. They build universal AI brains that can be retrofitted onto existing, cheap, modular hardware. This preserves architectural flexibility and prevents catastrophic CapEx losses if the technology pivots.
The blueprint also pushes coordinated capital for early-stage investors, demanding explicit institutional co-investment to de-risk these massive physical robotics bets.
because the hardware costs are just too high to go it alone.
Right. But let's circle back to the core danger we established, the determinism gap. The fact that the AI is guessing. TE vaults keep hackers out, and microfluidics keep the servers from melting. But neither of those things stops the AI from hallucinating bad physics inside the vault.
No, they don't.
So how do engineers actually force a guessing machine to produce mathematically guaranteed deterministic blueprints before a physical object is ever manufactured?
This brings us to what I consider the most conceptually radical technological leap in the entire 2026 blueprint. They are solving the verification problem using neurosymbolic AI secured by ancient Vedic logic.
Okay, I'm going to need you to hold my hand through this because my brain is really struggling here. We are using ancient Indian philosophy to secure 2026 server infrastructure.
It sounds crazy, but let's start with the baseline of how software is mathematically proven to be safe. It's a field called formal verification. Engineers use proof-oriented programming languages.
Yeah.
The text mentions Lean, Isabel, and Cock. Instead of just testing code to see if it crashes, they write complex mathematical proofs that guarantee the code satisfies a formal specification under every possible edge case in the universe.
So it's not a probability. The proof either holds or it fails. It's binary.
Exactly. It is absolute determinism. The problem is traditional formal verification is agonizingly slow. It takes decades of person-hours and PhD-level mathematicians to verify just a few thousand lines of code, like the kernel of an operating system.
So if an AI is generating millions of lines of code and massive CAD models every day, humans could never verify it fast enough.
Right. So the industry is converging LLMs with formal verification. They are using AI to write the mathematical proofs that verify the AI's own generated physical models. But to keep the AI from hallucinating the proof itself, they are integrating Indian knowledge systems, or IKS, specifically the ancient Vedic logic frameworks of Nyaya and Mimamsa.
Unpack the mechanism here. How does a philosophical framework translate into software architecture?
Well, the Nyaya School of Philosophy provides a rigid, highly structured, syllogistic framework for epistemology, debate, and the validation of truth, which is called pramana. Modern engineers are translating these ancient rules of logic into symbolic algorithms. They are building hybrid neurosymbolic AI architectures.
Neurosymbolic, so combining the neural network, the LLM, with symbolic logic, the fixed rules.
Precisely. It works through an adversarial multi-agent system. Agent A is the probabilistic neural network. It rapidly ideates and generates the physical design, say, the new structural support for an airplane wing.
It makes its highly educated guess.
Then it passes that design to Agent B. Agent B is the symbolic agent. It is programmed strictly with deterministic physical laws and the Nyaya syllogistic framework. Agent B's entire purpose is to engage in epistemological debate, known as Shastrartha, and logical inference, Anumana. It attempts to mathematically falsify Agent A's design.
Okay, I love this. It's like a high-speed digital courtroom.
That's a great way to put it.
Right. Agent A is this incredibly creative, blazingly fast, but slightly unreliable inventor. They throw down the blueprints for revolutionary new wing design. Agent B is an ancient, uncompromising, rigorous philosopher lawyer whose only job is to aggressively cross-examine the invention. Agent B uses the strict, unbreakable laws of physics and syllogistic logic to try and poke a hole in the math. And they debate each other back and forth millions of times a second until only the absolute mathematical truth remains standing.
That is a phenomenal visualization. This adversarial debate loop forces the probabilistic LLM to logically verify its own outputs before that data is ever deployed to a physical solver or a manufacturing floor. It actively prevents what the report calls regression to the mean.
Regression to the mean, meaning the AI defaulting to what is statistically common, even if it's factually incorrect for this specific physical anomaly.
Yes. The AI cannot just guess what looks mathematically plausible if it violates physical laws. The Nyaya logic framework, acting as the symbolic anchor, forces a deterministic validation. It guarantees the physics.
That is absolutely wild. We are binding the latent space of artificial intelligence with the epistemological chains of ancient philosophy.
To be beautiful in a way.
It is. But if you think that synthesis is wild, buckle up. Because this next part of the source material had me staring at the wall in disbelief for about 20 minutes.
The astrological master plan.
Yes. The entire strategic blueprint we've been discussing, the multi-agent systems, the microfluidic data center overhauls, the prompt engineering, the Nyaya formal verification, this entire Q2 2026 rollout is explicitly intentionally mapped to the Vedic astrology profile of a single human being.
Onto the hottest parts of the processor, vaporizing the heat away at a molecular level. It's the only way to manage the extreme thermal density.
The infrastructure costs for this transition must be astronomical. And the blueprint details how capital markets are doing some wild financial engineering to pay for it. The old models of corporate debt are changing.
We are seeing enterprises issuing debt that is collateralized directly by high-end GPUs.
Wait, they're using graphics cards as collateral for corporate loans, like you would use a skyscraper or a fleet of airplanes.
Yes, exactly. Computational hardware is now treated as a highly liquid foundational asset class. We are witnessing circular investments within the AI supply chain, where key players buy hardware, sell compute power, and invest in each other using equity and processing power as a unified currency.
It's like compute power is the new gold standard backing the economy. And for venture capital and angel investors looking at this phase, the software as a service gold rush of the early 2020s is definitively over.
Without a doubt.
The VC directive here is to pivot heavily to deep tech, robotics, semiconductor design, and simulation to reality infrastructure. But the text explicitly states that founders must demonstrate a design for retrofit philosophy.
This is crucial for hardware startups. In the past, a robotics company would spend $50 million building a custom physical robot from scratch. If the market shifted, they went bankrupt because the hardware was fixed.
So what's different now?
Design for retrofit means the startup prioritizes the intelligence layer, the AI brain, over the physical chassis. They build universal AI brains that can be retrofitted onto existing, cheap, modular hardware. This preserves architectural flexibility and prevents catastrophic CapEx losses if the technology pivots.
The blueprint also pushes coordinated capital for early-stage investors, demanding explicit institutional co-investment to de-risk these massive physical robotics bets.
Because the hardware costs are just too high to go it alone.
Right. But let's circle back to the core danger we established, the determinism gap. The fact that the AI is guessing. TE vaults keep hackers out, and microfluidics keep the servers from melting. But neither of those things stops the AI from hallucinating bad physics inside the vault.
No, they don't.
So how do engineers actually force a guessing machine to produce mathematically guaranteed deterministic blueprints before a physical object is ever manufactured?
This brings us to what I consider the most conceptually radical technological leap in the entire 2026 blueprint. They are solving the verification problem using neurosymbolic AI secured by ancient Vedic logic.
Okay, I'm going to need you to hold my hand through this because my brain is really struggling here. We are using ancient Indian philosophy to secure 2026 server infrastructure.
It sounds crazy, but let's start with the baseline of how software is mathematically proven to be safe. It's a field called formal verification. Engineers use proof-oriented programming languages.
Yeah.
The text mentions Lean, Isabelle, and Coq. Instead of just testing code to see if it crashes, they write complex mathematical proofs that guarantee the code satisfies a formal specification under every possible edge case in the universe.
So it's not a probability. The proof either holds or it fails. It's binary.
Exactly. It is absolute determinism. The problem is traditional formal verification is agonizingly slow. It takes decades of person-hours and PhD-level mathematicians to verify just a few thousand lines of code, like the kernel of an operating system.
So if an AI is generating millions of lines of code and massive CAD models every day, humans could never verify it fast enough.
Right. So the industry is converging LLMs with formal verification. They are using AI to write the mathematical proofs that verify the AI's own generated physical models. But to keep the AI from hallucinating the proof itself, they are integrating Indian knowledge systems, or IKS, specifically the ancient Vedic logic frameworks of Nyaya and Mimamsa.
Unpack the mechanism here. How does a philosophical framework translate into software architecture?
Well, the Nyaya school of philosophy provides a rigid, highly structured, syllogistic framework for epistemology, debate, and the validation of truth, which is called pramana. Modern engineers are translating these ancient rules of logic into symbolic algorithms. They are building hybrid neurosymbolic AI architectures.
Neurosymbolic, so combining the neural network, the LLM, with symbolic logic, the fixed rules.
Precisely. It works through an adversarial multi-agent system. Agent A is the probabilistic neural network. It rapidly ideates and generates the physical design, say, the new structural support for an airplane wing.
It makes its highly educated guess.
Then it passes that design to Agent B. Agent B is the symbolic agent. It is programmed strictly with deterministic physical laws and the Nyaya syllogistic framework. Agent B's entire purpose is to engage in epistemological debate known as Shastrartha and logical inference Anumana. It attempts to mathematically falsify Agent A's design.
Okay, I love this. It's like a high-speed digital courtroom.
That's a great way to put it.
Right. Agent A is this incredibly creative, blazingly fast, but slightly unreliable inventor. They throw down the blueprints for revolutionary new wing design. Agent B is an ancient, uncompromising, rigorous philosopher-lawyer whose only job is to aggressively cross-examine the invention. Agent B uses the strict, unbreakable laws of physics and syllogistic logic to try and poke a hole in the math. And they debate each other back and forth millions of times a second until only the absolute mathematical truth remains standing.
That is a phenomenal visualization. This adversarial debate loop forces the probabilistic LLM to logically verify its own outputs before that data is ever deployed to a physical solver or a manufacturing floor. It actively prevents what the report calls regression to the mean.
Regression to the mean, meaning the AI defaulting to what is statistically common, even if it's factually incorrect for this specific physical anomaly.
Yes. The AI cannot just guess what looks mathematically plausible if it violates physical laws. The Naya logic framework, acting as the symbolic anchor, forces a deterministic validation. It guarantees the physics.
That is absolutely wild. We are binding the latent space of artificial intelligence with the epistemological chains of ancient philosophy.
To be beautiful in a way.
It is. But if you think that synthesis is wild, buckle up. Because this next part of the source material had me staring at the wall in disbelief for about 20 minutes.
The astrological master plan.
Yes. The entire strategic blueprint we've been discussing, the multi-agent systems, the microfluidic data center overhauls, the prompt engineering, the Naya formal verification, this entire Q2 2026 rollout is explicitly, intentionally mapped to the Vedic astrology profile of a single human being, an individual named Prasad Blunde.
It is deeply unconventional. But from a systems thinking perspective, it is a fascinating attempt to solve a core problem of human-machine integration.
How does a corporate board approve a multi-billion-dollar tech rollout based on a guy's horoscope? Break down the logic here.
Well, the report argues that to effectively deploy advanced AI systems, the human operator's internal cognitive framework must be perfectly aligned with the external technological architecture. Integrating LLMs into physical engineering isn't just a software patch. It requires a unique synthesis of analytical communication, structural discipline, and execution-oriented drive from the humans running it.
Okay.
The authors use Prasad Bond's astrological chart as the foundational lens, a personalized architectural blueprint to map out these required cognitive states.
Okay, we have Prasad's Smart Kundalini report right here. Yep. Let's walk through the actual mechanics of how they translate planets into code. Prasad was born November 10th, 1999 in Mahal, Maharashtra. What are the key planetary alignments, and how on earth does this strategy report translate them into AI engineering?
Let's start with the ascendant. Prasad's profile indicates a Gemini ascendant, or Mithuna Lagna. The ascendant lord is Mercury, which is positioned in the 6th house in Scorpio.
The Kundalini report says Mercury represents communication, trade, intelligence, and a logical dialogic mind. It's the fastest moving planet. And the 6th house placement, according to the text, is all about analytical problem solving, meticulous detail, and overcoming obstacles.
Now look at the technological translation in the blueprint. In the context of 2026 AI, Mercury's high-velocity communication and algorithmic structuring of information represents the exact cognitive faculties required for advanced prompt engineering, LLM architecture design, and complex API orchestration. The 6th house placement, overcoming obstacles through meticulous logic, translates directly to the capability to resolve the data safari we discussed earlier.
That is uncanny. Mercury in Scorpio equals mastering the data safari through high-velocity prompt engineering. What's the next planet?
Next is Mars, positioned in Sagittarius in the 7th house. The Kundalini tells us Mars is the most powerful planet in this specific chart, symbolizing fire, energy, mechanical engineering, and people working with machines. It represents raw physical execution.
And the strategy report links this to the bridge between digital ideation and physical deployment. It represents the literal transition from generative AI to physical AI. Mars governs the hardware, the robotics integration, the point where the software touches the steel.
Precisely. Mercury is the digital intelligence. Mars is the physical machine. But as we established, you cannot let the machine operate without strict determinism. Which brings us to Saturn, located in Aries in the 11th house.
Right. The Kundalini describes Saturn's astrological function as restriction. It limits, disciplines, and balances the expansive, fast-moving nature of the other planets. It represents structural discipline and boundaries.
In the realm of AI engineering, Saturn is the mirror image of formal verification. It is the deterministic discipline required to prevent the expansive probabilistic LLMs from executing flawed physical models. It represents the confidential computing teas and the Naya debate loops. Saturn enforces the physical safety parameters.
So Saturn is the uncompromising philosopher-lawyer. This is blowing my mind. Finally, the chart looks at the timeline, the current Vimshottari Dasha period. Prasad is in the Venus-Rahu-Rahu phase, active through late 2028. Rahu is positioned in the second house in Cancer. The astrological translation here is technological disruption and inclination toward unconventional research and automation.
And the engineering application for this Rahu phase in 2026. The aggressive implementation of agentic AI, autonomous multi-agent systems disrupting legacy workflows.
The strategy report literally uses Prasad's Varshfal report, his annual personalized horoscope, to dictate the corporate directives for the months of March, April, and May 2026. Let's look at this execution blueprint.
We begin with Phase 1, Foundation, in March 2026.
The Varshfal forecast for Prasad in March indicates a period of grounded stability, encouraging growth through consistency and avoiding risky leaps. The text says this perfectly aligns with the initial phase of AI deployment, data foundation, and preparation.
The primary strategic objective for March is data structuring and stability. The corporate directive is that before autonomous agents can be deployed into physical workflows, the underlying data environment must be structured. You have to resolve the data safari.
So engineering teams must spend March deploying LLMs to index, cross-reference, and structure all legacy test results, vendor specs, and material properties into unified formats.
Furthermore, they must formalize context engineering across the workforce. Organizations must establish enterprise-wide prompt libraries. Employees must be trained to break complex tasks into smaller, verifiable steps. It's about building foundational reliability and avoiding excessive, risky automation to ground the AI integration.
Which brings us to Phase 2, verification, in April 2026. The Varshfal forecast for April highlights a period of quiet, deep focus where external noise diminishes and internal rigor takes over.
This astrological environment is highly conducive to the most rigorous phase of the rollout, determinism and governance. With the data structured in March, April is dedicated to establishing the deterministic boundaries around the AI models.
This is the month they implement the neurosymbolic architectures, the Naya-based multi-agent debate loops, executing the formal mathematical verification.
Yes, and at the executive level, April is the month for strict governance, deploying AI transparency cards so teams understand the limitations of their models. Crucially, this is when IT leaders must transition physical workloads into those confidential computing TEs to protect the infrastructure. The entire focus of April is establishing the absolute presence of security.
And then we hit the climax in Phase 3, deployment in May 2026. The Varshfal predicts May will introduce high velocity, rapid communication, and the complex juggling of overlapping projects.
Which perfectly mirrors the reality of deploying agentic AI. The strategic goal for May is agentic interoperability.
This is where they take the leash off, activating cross-functional AI agents simultaneously. The report gives the example of a material planner agent, a commercial agent, and a demand forecast agent collaborating to execute supply chain renegotiations autonomously in real time.
But to manage this high-velocity complexity safely, the directive states organizations must establish strict human handoff protocols. The AI must operate within tightly defined triggers and boundaries, always returning control to human engineers for final design judgments or final financial sign-offs above certain thresholds. Employees are explicitly directed to prevent feature creep during May and focus exclusively on deploying the verified models into live production.
I'm absolutely floored by how tightly the astrological predictions match the engineering rollout phases, and the Varshfal report even has personalized physical remedies for these months.
Yes, the grounding rituals.
In March, to cultivate steady energy for data structuring, the remedy is to drink warm water with honey on Tuesdays, avoid fried food, and do a 10-sentence writing drill. In April, for the stability needed in formal verification, keeping raw turmeric in your puja room and donating yellow fruits. In May, for the endurance to manage high-velocity agents, fasting on Saturdays and offering cooked rice with jaggery to stray animals. It's fascinating how these personal, physical grounding rituals are mirrored by the corporate grounding of the AI architecture.
It speaks to the holistic cybernetic nature of this shift. The human operators must be internally disciplined and physically grounded in order to architect externally disciplined, physically grounded machines.
All right, let's zoom out from the data centers and the astrology charts. Let's look at the macro level. We've talked extensively about code, silicon, and supply chains, but what does this look like out in the dirt? Where's the physical proving ground for all of this in 2026?
The blueprint highlights the state of Maharashtra, India, as the premier macroeconomic and industrial case study for the real-world deployment of physical AI.
Why Maharashtra specifically?
It possesses the perfect storm of scale and industrial focus. It boasts a projected economic growth rate of 7.9% in FY26, outpacing the national average, and contributes over 15% of India's entire industrial output. More importantly, the region's industrial policy, the MIISP 2025-2026, is heavily focused on frontier manufacturing, semiconductor fabrication, optics, sensors, and autonomous drone logistics. It is a massive real-world sandbox for hardware-software convergence.
The text gives a highly specific example in the agricultural sector in the Jalgaon district.
Yes. Jalgaon is deeply invested in agriculture and polymer pipe manufacturing. The integration of multimodal LLMs and physical AI is revolutionizing resource management there, specifically with low-volume irrigation or LVI systems.
Global freshwater scarcity is one of the most pressing physical crises we face. How is AI fixing irrigation pipes in the dirt?
The manufacturing of these subsurface drip irrigation pipes now integrates advanced polymer science with IoT sensors and AI-driven scheduling software. The multi-agent systems use LLMs to continuously ingest and analyze real-time meteorological data, localized soil moisture sensor readings, and multispectral satellite imagery.
So the AI agent is simultaneously looking at the weather forecast, analyzing the chemical moisture of the soil, and looking at satellite photos of the crop canopy, and it dynamically decides exactly when, where, and how much to water.
Precisely. It delivers water drop by drop exactly to the root zone based on predictive algorithms. The result is a staggering reduction in water consumption by up to 50% while drastically enhancing crop yields.
A 50% reduction in agricultural water use through AI optimization is a world-changing metric. But this raises a massive practical bottleneck. How do you get complex multimodal AI software into the hands of a regional farmer in Jalgaon? Or an informal sector worker on a factory floor? You can't just hand them a 20,000-word Dieter Rams prompt guide and tell them to practice context window orchestration.
That is the crucial last mile of physical AI, and it is solved by what the sources call sachet AI.
Sachet AI, like a small single-use packet of shampoo you'd buy at a local kiosk.
Exactly. The knowledge gap created by literacy barriers and complex engineering interfaces is being bridged by domain-specific vernacular LLMs. The source text specifically names a model called Danu 1.0.
How does Danu 1.0 actually function on a low-end mobile device in a field?
It relies on edge computing and heavily quantized neural networks. Instead of sending data to a massive, power-hungry server farm, the model is compressed to run locally on the device. Sachet AI provides bilingual, voice-based conversational interfaces. A farmer doesn't need to type code or understand data structures. They simply speak to the device in their native dialect, asking about soil moisture or pest control.
That's amazing.
The AI translates the voice to text, queries the optimized local model, and speaks the solution back. It provides highly specialized, low-cost, bite-sized access to advanced intelligence. This sachet approach is the only way to scale adoption across the informal sector and small-scale manufacturing.
Which perfectly sets up our final directive from the Q2 blueprint, the marketing directives. If you are a marketer or product manager listening to this, the game has fundamentally changed. The report states unequivocally, B2B marketing based on generic AI hype will fail in 2026.
Because of the massive proliferation of AI-generated content over the last 3 years, there is profound fatigue and skepticism among professional buyers. To establish thought leadership, marketers must enforce strict anti-AI writing principles.
They call it avoiding regression to the mean. You cannot use generic, overwhelmingly positive descriptions that puff up the technology. The text gives explicit instructions to eliminate cliché status phrases. Do not say a product stands as a testament or marks a pivotal turning point, or talk about the evolving landscape.
Because that is exactly how unprompted, lazy LLMs write. The Notebook LM Guide calls it synthetic slop. When an engineering buyer reads the word tapestry or testament, their brain instantly flags it as machine-generated fluff, and you lose all credibility.
So what do enterprise buyers actually demand to see in Q2 2026?
They demand extreme specificity in raw data. They want the exact mechanisms of action. They want the security protocols explicitly mapped out. They want the mathematical proofs of ROI. Marketers need to stop selling AI magic and start presenting the mechanics of formal verification. They need to explain the exact cost savings of microfluidic coding architectures or detail the precise failure modes of probabilistic LLMs and how their product mitigates them. In this new era, specificity beats generic every single time.
And for product positioning, they advise adopting that Sanchez AI model mindset, offering tools that solve immediate hyper-niche problems with zero friction, rather than selling massive, bloated platform transformations. The focus must be on authentic, idiosyncratic human formatting to build trust in a landscape completely saturated with machine-generated noise. Well, we have covered an absolutely massive amount of terrain today. Let's summarize the key directives we've extracted from this wild stack of sources.
We have tracked the definitive boundary in the evolution of artificial intelligence. The shift from chatbots confined to digital conversational interfaces to the era of physical AI autonomous multi-agent systems directly manipulating the physical world, from routing global supply chains to executing complex CAD models.
We outline the critical directives for C-level leadership.
Yeah.
The linear supply chain is dead, so shift your CapEx to agentic AI. And audit your data centers immediately, because if you aren't preparing for microfluidic direct-to-chip cooling, your infrastructure cannot support the thermal density of the next generation of silicon.
We explored the terrifying reality of the determinism gap and why board members must immediately mandate confidential computing keys, those VIP silicon vaults, to protect physical infrastructure from the statistical hallucinations of probabilistic guessing machines.
We dove into the fascinating esoteric integration of ancient Vedic logic, specifically Nyaya and Mimamsa, to create adversarial debate loops that force these AIs to produce mathematically guaranteed formal verification of their outputs.
And we traced how this entire Q2 2026 strategic rollout, from structuring the data safari in March to rigorous governance in April to high-velocity agentic interoperability in May, is uniquely and deliberately timed and mapped to the astrological and cognitive framework of Prasad Bond's Vedic chart.
Whether you are a junior engineer writing strict utilitarian 20,000-word prompts using the D to Rams philosophy, or a CEO restructuring your corporate debt by collateralizing your high-end GPUs, you are living through a profound cognitive shift. You are part of the movement from probabilistic ideation to deterministic execution.
The integration of physical AI requires us to fundamentally change how we evaluate truth, how we structure our internal cognitive frameworks, and how we secure our shared physical reality.
Which brings me back to where we started this conversation, that suspension bridge. We build our world on the expectation that things are clean, visible, and binary. Broken or not broken, standing or falling. As we move headfirst into this era of physical AI, we are demanding that same flawless binary perfection from machines that were originally architected simply to guess the next word in a sentence. We are forcing them to be perfect by binding them with ancient philosophy, and we are timing their deployment to the movements of the planets. So I will leave you with a final thought to ponder as you look at your own corporate strategy for the months ahead. As we embed these highly advanced autonomous agents into the very bedrock of our physical infrastructure, governing our water systems in Maharashtra, our server buildings, and our global supply chains using hybrid neurosymbolic logic, are we simply building better tools? Or, by giving these systems physical agency, mathematical logic, memory, and a rollout timeline mapped to the stars, are we actually engineering a completely new collaborative species to share the physical world with? Thank you so much for joining us on this deep dive. Keep exploring, keep questioning, and we will see you next time.